On the set of axes below, graph the following system of inequalities. And it gives us the two inequalities. So notice neither of these inequalities are in point slope form. So we want to isolate our variable y. So let's take this expression, this inequality here, and we'll write it down here. And let's get it in y. Let's isolate y. So 2y plus 3x is less than or equal to 14. So we're going to subtract 3x from both sides. And we're left with 2y is less than or equal to negative 3x plus 14. We divide by 2 on both sides to isolate y, and y is less than or equal to negative 3 over 2x plus 7. So this is one expression taken care of. Right, the next expression is 4x minus y. So 4x minus y is less than 2. So here we're going to subtract 4x from both sides to isolate y. And we're left with negative y is less than negative 4x plus 2. And now we need to divide by negative 1 on both sides to get rid of the negative. When we divide or multiply by a negative, remember the sign changes direction. So instead of being less than, it's now greater than. 4x minus 2. So in the blue equation, the sign didn't change because we divided by a positive. But in the purple equations we're looking at, we divided by a negative, so it changed sides. All right. So now we're going to graph these two equations. So the blue equation has a y-intercept of 7 and a slope of negative 3 over 2. So we go down 3 into the right 2. Then we go down 3 into the right 2. Down 3 into the right 2. And the line will be will be solid because it is less than or equal to. So the line is going to be positive. Not positive, solid, because it's less than or equal to. And because it's less than or equal to, we're going to shade everything below the line. If it were greater than, we would shade everything above the line. All right, now let's graph the purple line. So it has a y-intercept of negative 2. So a y-intercept of negative 2 and a slope of 4. And a slope of 4. So rise 4 into the run to the right 1. So rise is 4, run is 1. So rise 4, run 1. And then we go down and to the left. And here, because it is just greater than and not greater than or equal to, the line will be dotted. So y is greater than 4x minus 2. And because it's greater than, we're going to shade everything above the line. So the solution sets will be anything that's shaded both purple and blue. So the question is asking us to see, is the point 1, 2 in the solution set? So let's look at the point 1, 2. The point 1, 2 is on the dotted line for being on the dotted purple line. The dotted line is not inclusive. It does not include that value. So the point 1, 2 is not in the solution set. So the point 1, 2 is not in the solution set because it is on the dotted line, meaning it is non-included. And we can show this algebraically. Algebraically, we can plug it into the equation y is greater than 4x minus 2. And we can substitute in our values. So y is 2, so 2 is greater than 4 times 1 minus 2. And we'll see that 2 is greater than 4 minus 2. And 2 is not greater than 2. This would hold true if 2 is greater than or equal to 2. So we can see that algebraically it also does not hold true. If the line were solid, if this were like this, right? If it included the lines of having an equal sign, so greater than or equal to, then it would hold true. And it would be in the solution set. But in this case, it is not.